introducing any of the new methodology or any of the new objects, that needs to be well maintained as in the terms of documentation. After the development of a software or a development of a project, it will going to be validated against this requirement. When we follow certain stages or a phases in order to build a software, then we are going to call that standard as a SDLC or a software development life cycle. Hello everybody, a warm welcome to one and all. Welcome back to the last session of B.C.A 6th semester subject called Software Engineering, and we are in the Unit 1. So today we'll see about the life cycle model continuation part. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So before getting into today's session, let me have a quick recap of my previous session. So in the last session of this unit, we have discussed regarding the spiral model. It is very important. So each spiral model will going to divide it into 4 quadrants, and in each 4 quadrants we are going to have, or we will perform some of the operations. So this loop indicates that one phase of a development of a software, and also I have discussed regarding what are the advantages and disadvantages we have and how risk will going to be managed with the help of this spiral model. That is what I have discussed with respect to the spiral model. And also we have done the discussion regarding prototyping model. It's a dummy model. We are not creating the actual one. Instead of that, by taking the requirements of a customer, we will start working towards to the core part. So there they will just build a dummy model, which is the virtual one, which will be given to the customer. If they are okay with that particular development of a project or a software, then they will start working towards the actual one. That is regarding prototyping model and big bang model. So when the customer don't know their requirements, and even developer don't know which methodology to use, their main only concern is regarding time as well as the effort, and output we are going to get as a software. And also I have discussed regarding the advantages and disadvantages of all the models in my previous session. So in our today's session, we'll have 2 more models, which includes object-oriented model, and also we'll see about the verification and validation model. In short, it is considered as a V model. So that is verification as well as the validation. So we'll see what this validation and verification model is all about in our today's session. Along with that, we'll see what is system engineering. So we know software engineering, but then what about the system engineering? We'll see now. And also computer-based system. So which are the system which based on the computer technology or tools and techniques which we are going to use, that we can see in the computer based system. And also we have a system design hierarchy. So this design part is one of the stages in a SDLC or a software development life cycle. So how this can be, complexity can be reduced, what are the methods we have in that design hierarchy, that we'll see in our today's session. So now we'll see about this object oriented model. So as we all know that object is a real world entity. Can we represent anything as an object? Yes. So when any of the real world entity has an ability to express itself in the terms of its behavior and in the terms of its characteristics, then we can call that as an object. For example, if I consider this a digital pen, how can I represent or how can I recognize this as a digital pen? Because it has some of the characteristics, it has some of the features, and it will going to perform some of the operation. For example, it has height, it has color, and it belongs to some company, and it has cost. All those are the feature. What are the operations we can do? So we can write with the help of this. So we can erase the content, we can select the color. So those are the operations which can be done with the help of this one. That means any of the object, it's a real world entity which will going to have its own features as well as the behavior or a functionality. So in the object oriented model, they will first pick up any of the design module. So in the previous session we have discussed regarding different kinds of models. So out of that model we are going to get the product or a project or a software as a resultant. They will just take that software as an input for the object oriented model. Then they will start finding the objects which are the possible objects that we have in the product or a project. Then they will model, or then they will work with that in order to identify what is the object and how it is related to another object, how to analyze that object. Everything will going to be done in this object oriented modeling. So that object oriented life cycle model consider objects as the basic of the software engineering process. everything will be considered as a object. If it is a collection of an object, then that will be a class. So class or a object is an instance of a class. So that's why everything will be considered as an object here. And also the development team starts by observing and analyzing the software they intended to develop before defining the requirements. First, we have to focus on observing and analyzing what are the objects that I can get in a particular system that they have to analyze and to design. So once the process is over, they focus on identifying the objects of the system. So before the development of any of the software or a product, they will observe and they will analyze what are the objects that I can get in a particular system or a software. This is how this object oriented model will going to work. Everything will be considered as an object. If I wanted to consider that as an object, that must have features as well as the behavior, so that you can see the primary objectives of the object oriented model. First, as I told, it needs to be analyzed. Object oriented analysis. Can I consider this pen as an object? Yes. Then how can I consider this as an object? So I have to be justified with a clarification, so that analysis in the sense what? They have to do the analysis, or they have to analyze the content, whatever we can expect from the object. So once it is analyzed, then that needs to be designed. So here we are going to create a relationship between one object to another object. What is the association between the two objects and how it needs to be represented. All those will come under the design part. And also object oriented implementation. With the help of some of the object oriented programming language, they are just going to implement the design whatever has been analyzed in all the stages. So these are the primary objectives. Then what are the methodologies that we have in the object oriented model? So first is object identification. If I wanted to analyze it first, then I have to identify what are the objects that I have in a system, so that system objects and their characteristics and events are identifiable. So once the system objects and their characteristics, as I told, its features, characteristics, and what are the operation it will going to perform, if I get to know regarding that, then it will be easy for me to do the modeling. So that first phase, they have to identify the object. So now I got to know which are the objects which we have in my system. So then that object needs to be organized, that needs to be arranged, so that this will shows how objects are related via part of relationship, how one object is associated with another object. The relationship between those objects of a particular system will be identifiable and organized in the second methodology. And we have an object interface. As I told, if you wanted to share a message, there must be a communication between one object to another object, then there must be an interface, then there must be a media in order to have a conversation, so that that interface shows how objects interact with other objects. This mainly shows what? How one object will going to be interact with another object. First, I have to identify the object, then identifiable or identified object needs to be organized. That means we have to take this object belongs to which category or a class, that object belongs to which class. So we have to do the identification as well as the organization. Once it is organized to a particular part of relationship or particular part of class, after that, that needs to be interface. That means we have to create a connection between one object to another object in order to establish the communication between the objects. So these are the methodologies that you can expect in the object oriented model. So then you can see the diagrammatic representation of an object oriented model here. First, requirement will be analyzed, then they will specify the system specification, their functional and non-functional specification will be specified here. So once they got the documentation form, they will start with designing that. Once the designing is done, they can go with the implementation, or else they can go with the planning. Further planning, can I consider this as an object? What is the relationship between those two? All those phases can be further proceed. So whatever the plan they are doing, everything needs to be well documented, so it will be further useful. And also after the implementation, they will use that for the documentation purpose. Once the implementation is over, that means once the coding is over, they will test the objects whatever they have built So once the testing is over, then it will be of maintenance. So this maintenance will be a throughout purpose. That means it will be a continuous process. Once the requirement analysis is done, that will be maintained throughout the lifetime of a software or a product, and it is like bi-directional. Once the requirement analysis is done, again they can go with the design analysis and implementation, testing. All those phases will going to take place again and again here. If they are introducing any of the new methodology or any of the new objects, that needs to be well maintained as in the terms of documentation, so that one object will going to be communicated and it will going to have an interface with the help of all these strategies. I hope you all understood. Let me have a object oriented models, advantages as well as the disadvantages. By getting to know about the object, we can easily say that it reduces the maintenance. Why? Because this is more flexible, it will be simple, so it will be easy for the maintenance purpose. Why? Because if I categorized it or if we organize the objects in a particular or a proper manner, then it will be easy for the purpose of maintenance and also real world modeling. So as I told, I can take this as an example. In the same way, whatever the real world objects that we have, everything can be modeled with the help of this object oriented methodology, and also it improves the reliability and flexibility. Reliability in the sense, what can we trust this? Yes, so that is what reliable. So here reliability stands that up to what potential, up to what certain things it is able to produce a good result in. That is what reliable, and it is flexible. If I wanted to add one more objects to the existing class, I can add it. If I wanted to remove, then we can also do that. That is what it will going to improve the reliability as well as the flexibility and high code reusability. So one object code can be used in another project. Reusability of object oriented programming is very higher. That is also one of the advantage. And if it is data focused and easy to work with the problem domains, if we get to know what data is focusing is all about, then it will be easy for the development of a software. And also mainly it uses the encapsulation as well as the data hiding. Let me give you an example. We all know how to use a refrigerator and how to work with a washing machine, but do you really know how it is working internally, like how spinning is taking place, on what criteria, on what number of scheduling algorithm it is working? Do we know exactly how it is working internally? No, right? We just know only the essential features. That means we just know how to use it instead of thinking about its all background implementation. That we can say that as a data hiding. So if you consider the data encapsulation, here it's a bundling of both data and functions together. If you consider the capsules medicine, that is what encapsulated together, right? All the medicine will be inside that wrapper. So what they are doing, they are combining or they are wrapping the both data as well as the function in a single unit. So that is also possible when we have this object oriented modeling. So you can expect encapsulation and data hiding. If there is a data hiding, then it will going to improve the security and confidentiality will be more. This will help in order to build a tamper proof system. So that means there is no data or information leakage to the outside system. And also this enables the software modularity. I can't consider, or when we are working with this object oriented model, at the time they will divide everything as an object, right? So modularity in the sense what? It will not be considered as a single complex problem. Instead of that, it will be divided into number of sub-modules or a sub-problem, and it will be easy for the purpose of maintenance as well as complex software can be easily maintained. And also this allows the developers in order to create a new modules using existing module. That is what related to reusability terminology. So these many advantages we have in object oriented model. Then there must be a disadvantages also, right? What is that? We'll see now. When it comes to the disadvantages, object-oriented development is not a panacea. There is no standard for the object-oriented programming or object-oriented methodology, however you wanted to use. So that means development is not a technology here. There is no standard. However you wanted to use the object-oriented modeling, you can use it. That is the main drawback of this object-oriented model, and also development is not yet completely accepted by major vendors. As I told, if there is no standard, if it is not following any of the methodology properly, then somehow the vendors will not going to accept this type of modeling, and also cannot find qualified programmers and database administrator. So when there is no standardization, when there is no set of rules or regulation to have this object oriented modeling, at that time we can't expect a well or experienced qualified programmers or what expertise DBAs or a database administrator out of this. So these are the advantages we have. We'll see the next one, that is with respect to verification as well as the validation modeling. So here verification and validation, it will going to form a V. That's why we are going to call this model as a V model as well. So this side it is verification, this side it is validation. We'll see now. Verification and validation is the process of investigating that software system satisfies the specification and standard and it fulfills the required purpose. So here we are having both verification and validation, right? So verification in the sense what customer will going to give all their requirements what they wanted to have in the software or a product, and validation in the sense we are checking all the requirements which is given by the customer is satisfied or not. That is validation. Verification taking all the requirement and verifying is all the requirements is going to satisfy the requirements of a customer. So in the validation they will check against the requirement whether it is satisfied or not. So as per the Barry Boehm, they have described the verification and validation in a beautiful words. So here as per the Barry Boehm, what is verification here? Are we building the product right? And validation in the sense, are we building the right product? So here there is a difference. Are we building the product right? Now build ಮಾಡ್ತಾರ product correct ಆಗಿದೆಯಾ? Then here are we building the right product? Now build ಮಾಡಿದ product correct ಆಗಿದೆಯಾ? That's what verification and validation. So here I'm just checking or we are just verifying that are we building the product right? Now correct ಆಗಿರೋ product ನ build ಮಾಡ್ತಾ ಇದೀವಾ? So in the verification. After that now build ಮಾಡಿದ product correct ಆಗಿದೆಯಾ? That is validation as per the requirement of a customers. So these two lines of statement is very important when you are writing about this verification as well as the validation model. And also you can see about this verification right now. It's a process of checking that the software achieves its goal without any bugs. So are we building a product right? That is in the verification. We are checking, are we satisfying all the requirements? Are we including all the requirements without any errors or bugs? So that it is a process to ensure whether the product that is developed is right or not. Now build madira product correct ಆಗಿದೆಯಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡೋದು, that is what verification. So correct ಆಗಿರೋದನ್ನ develop ಮಾಡಿದೀವಾ ಅಂತ ಚೆಕ್ ಮಾಡೋದು validation. So that in the verification this will going to ensure that whether the product that is developed is right or not. And also in this verification, after the development of a product, they will just verify that whether it will going to fulfill all the requirements of a customer which is have given. So that is what verification. And also we can call this verification is a static testing. Already we have built, we are just checking whether its a proper requirement has been included in the product or a project or a software is or not. That is what verification. And also activities which is involved in the verification, we can have a inspection, we are checking that, and also reviews, we are taking a feedback, and also we have a walkthroughs, then desk checking. So these are the activities which will going to be performed in the verification part. So then what about the validation? So here you have to remember one thing. For verification it is PR. Are we building a product? Right. For validation, it is RP. Are we building a right product? So, PR, RP. In this way, you have to remember, then it will be easy for you. So, verification. So, verification in the sense what? Are we building a product right? And validation. So, are we building a right product? That is the difference. We'll see about the validation here. So validation is a process of checking whether the software product is up to the mark, or in other words, product has high level requirements. Already I have given the requirements in the verification. After the development of a software or a development of a project, it will going to be validated against this requirement. Is all the requirements of a customer, whatever they have given, is satisfied or not? Are we build a right product or not based on the requirement? So that it's a process of checking the validation of a product, and also it checks what we are developing is the right product. Are we developing a right product is what validation, and also it is the validation of an actual and expected product. So in the expected product, they are going to give you the certain number of requirements. In the validation, we can have the actual product. Both actual as well as the expected model will going to be compared together. It will be verified as well as validated. So if both get matched, then we can say that they have produced, or development team has given the efficient as well as the effective model. And also we can say that validation is the dynamic testing. Verification is static and validation is dynamic testing. So in the validation, they are having the testing activities that includes black box testing, and also we have a white box testing, unit testing. Each module will be tested independently, and also we have a integration testing. For example, if we have a 5 modules, each module will going to be tested independently. After that, one module will going to be incorporated with other, then they will do the testing. So if both are compatible or interoperable, then it will be merged with another model. So if it's all are working fine, at last they are going to have a system testing. So these activities which comes under this validation. So here you can see the diagrammatic representation of V model. So here this side it's all about verification, this side it's all about validation. First they will collect the requirement, then they will analyze, after that they will do the system designing, then architecture design will take place, after that module design will going to takes place. So once all the requirements is collected from the user or a customer, it will start working with a coding. So in the coding part, they will do the calculation, implementation, all those will going to take place here. After that, unit testing, that means each module will be tested independently, then they will merge with another modules, then integration testing will going to take place, and system testing, at last user acceptance testing. So if the user accepted as per their requirements, then we can say that verified as well as it's validated as per the requirements of a customer. And also you can see that it is what bidirectional. So once the requirement is taken from the customer, so at the time they are going to accept whatever the requirements which is given by the user, then that will be tested, and in return they will give the user acceptance testing at initial stage itself. And also system design. System is designed, then again it will be directly given for the system testing. So if they are accepting, they will go further. So this is how all these stages will going to takes place or carried out in a V shape. Verification, so they will check, are we building a product right? So here, are we building a right product? That is verification as well as the validation. So in the verification, all the designing and requirement collect will take place. At middle we have a coding. In the validation part, we have all the kinds of testing up to the user acceptance testing. So if the user accepted a produced product, then we can say that all the requirement which is given by the user got satisfied or accepted. It's all about regarding V model or a verification and validation model. It's all about all the life cycle model. So we have a waterfall model, iterative waterfall model, we have a prototype model, spiral model, and also we have discussed regarding the object oriented model, then also about this verification and validation model. So these are the life cycle model what we have in the SDLC life cycle. So now we'll see about this system engineering. Already we know that engineering is a methodology, it's a management art. So then what about the system engineering? So that system engineering is a transdisciplinary and integrative approach to enable the successful realization, use and retirement of engineered systems using systems, principles and concepts and scientific, technological and management methods. So here we are having a reverse engineering here. That means whatever the system has been built and how it got used, and can we reuse it based on certain methodology, based on certain principle, concepts and also with the help of a technological team and a management method, they are just reusing it. That is what system engineering. So it's a transdisciplinary and integrative approach to enable the successful realization, use and retirement of a engineered system or a software. So by making use of a system principle, methodology, tools and techniques, main intention of the system engineering what? System has to work properly from the time of requirement gathering up to the maintenance and even retirement of that engineered system. It has to work properly. So in order to make it work properly, they are going to have some of the principle, tools, techniques, and also we have some of the technologies, concept, all the management methods. By integrating all these things, they are making a system work in a proper manner. That is regarding system engineering. Then what about computer-based system here? So here we have all the components which is necessary in order to capture, process, transfer for the purpose of storing and also displaying and manage the information components. So all the computer components or electronic components, whatever we are going to use in order to capture or to process, transfer and to store, display and management of an information components, and that include software, processors, we require networks for the exchange of information, we require buses, firmware, freeware and all the kinds of software along with the application specific integrated circuits, and also we require storage devices and humans. Mainly in order to work with a computer system, we require a humans when it is semi-automatic or when it is manual. At the time human is required, and also they are going to process the information. So all these bundled together will be considered as a computer-based system. So here it includes all the kinds of components or all the kinds of necessary elements which is helpful in order to get the information or to capture, to manage and to process or to transfer, store and to display all the information component whatever we are using in the system development. So that all these will together constitute is called as computer based system. And also computer based information system we have. So it's an organized integration of a hardware, software, technologies and human elements which is designed to produce timely, integrated and accurate useful information for decision making purpose. So here in the computer based information system, that is CBIS. So this is CBS, computer based system. Okay. So in the computer based information system, we are integrating all the hardware, software along with the human, which will going to include in order to have a timely, integrated, accurate and useful information and management of that information for the decision making purpose. This is regarding computer based system. So now we'll see about the SDLC, that is system or a software development life cycle. Already I have discussed about this SDLC or a software development life cycle. It's a methodology and it will going to be followed by a software project. So when we follow certain stages or a phases in order to build a software, then we are going to call that standard as a SDLC or a software development life cycle. And each phase or each level of any of the SDLC will going to have its own activities, and also life cycle defines a methodology for improving the quality of a software and overall development process. So when we have management, when we have a evolutionary model, all those will going to help us in order to improve the existing features. So that's why this life cycle is mainly used in order to improve the quality and quantity of a software and a well management of all those software. And also it will going to have certain stages which starts from a planning. So we have to plan first what the software or a product that we wanted to build. So once it is got planned or analyzed, then it will be given for the definition. So in the defining at that time, it will going to have a SRS or a system requirement specification. So there we can have a functional and non-functional requirements, and it's a contract between the development team as well as the customer. Once it analyzed as well as it will be documented, then it will be given to the designing part. So with the help of some of the designing or a schematic representation, they will design the requirement of a customer, then it will be given for the purpose of coding, or for the implementation called building. So once it is built, it needs to be tested, that is in the testing phase. So once it got tested, then it will be deployed to the user environment, then it is ready to use now. So you can see the stages whatever we have in the SDLC or a software development life cycle. In the first stage, planning and requirement analysis. Stage 2, defining the requirements. It will be of document type. Then designing the product architecture. Then once it is designed, they will start building or developing the product based on certain programming language and testing the product based on some of the testing methodology like black box, white box, and also we have a unit testing, integration, system testing, acceptance testing. By making use of all those technology, they will test the product. If it is all okay, then they will deploy in the market, and maintenance is the mandatory part which will help to improve or enhance the productivity and quality of a software in order to add certain features whichever is required as per the requirements of a customer. This is regarding stages of software development life cycle. Let me move to the last topic of your first unit, that is regarding system design hierarchy. Already I have discussed regarding what are the stages we have in a SDLC or a software development life cycle. So among that, design is also going to be a very important and mandatory part, right? So for the purpose of good system design, we are going to organize the program modules in such a way that they are easy to develop and to change. So if we design in a very well manner, then it will be easy for the development, right? So as we all know that one image is equal to 1000 words. Instead of saying 1000 words and giving a scenario about any of the situations, instead of that, if you are showing a pic or if you are showing an image, then easily people can understand. That is what design is going to do. If we have a good design of a software or a system, then it will be easy for the purpose of organizing the program into program modules into very easy manner, as well as it will be easy for the purpose of development. And if I wanted to do certain changes in the design part, then it is also easy. So that structured design techniques help the developer to deal with the size and complexity of a programs. So if it is everything is theoretical, if it's all in the form of documentation, somehow it will be difficult to read all the content. But if you are representing all these in the form of some structured design technique, at that time management of that complexity and managing the size or complexity of that system will be somehow easy than the documentation. So it will be easy for the analyst to create a design document with the help of good design or a system design. So that analysts create instructions for the developers about how code should be written and how pieces of code should fit together to form a program. So here analyst will going to say, like, by analyzing all the requirements of a customer, they will say that how to code it, what are the methodologies we can use, what are the tools and techniques that we can have in order to have a very well written program, and how the pieces of code should fit together to form a program. That means how one code of a program should match with another code, what must be the sequence of a programming. All those will be given by the analyst. By taking the suggestions from the analyst, this designer will going to design a very good system design that will be helpful for the understanding purpose, and it will be easy to develop and to make the changes. So here you can see the importance. If any pre-existing code needs to be understood, organized and pieced together. So if it is in a documented form, and after that documentation, if it is in a design form, then it will be very well easy for the purpose of understanding and to organize. And if I wanted to cut paste, or if we wanted to remove certain programming code, then it will be easy. And also it's common for the project team to have a write some code and produce original programs that support the application logic of a system. So initially it's like a trial and error. Say they will start writing certain code, and based on the design they will do the actual one. And also in order to have this system design hierarchy, we have three types. One is bottom up approach, another one is top down approach. If we integrate all both together, then it will be a hybrid approach. We'll see each type of approach for the best strategy or a technique which we can use in order to have a best or good system design. We'll see the first one, that is bottom up approach. As the name indicates, bottom up. So here you have to remember we have certain solution for a particular problem. It will be in the terms of modules. Okay. So it will be in the terms of module. Bottom up in the sense what? I have already predefined or pre-tested, preformed solution for a certain problem, right? So whatever the solutions I have, based on that solution and based on my complexity of a problem, I will choose all these solutions to find a solution for my complex problem. At the time, need not to include all the models whichever is available in the market. Based on the requirement of your solution or based on the requirement of your problem, you have to choose the solution which is already developed, tested as well as maintaining well. So I will give you one example to understand what is top down and what is bottom up. You just take the example of catering as well as the hotel. So in the catering, what will going to happen? Based on your requirement, based on the menu what you want, based on that you are going to give the requirement. I want curries, I want these many sweets or any of the spice food. That based on our requirement we are going to choose, then it will going to form a one meal, right? So that is what already we have certain modules which is already designed, developed, everything is done. Based on my requirement, I will choose any one of that solution to find a solution for my problem. That is bottom up. Then what about hotel menu? Already it's predefined, already they have set some of the standards or they have include some of the dishes there, right? So, based on my complexity, for example, if I wanted to have a North Indian thali, so at the time, they are going to have a predefined set of dishes over there. If I like that, then I can choose that. But that is just a reverse of this catering or any of the other type of food ordering theme, right? So, that is the difference between bottom up as well as the top down approach. So, in the bottom up approach, the design starts with the lowest level components and subsystem. So, here we are going to have a lower level of modules or a subsystem. Based on my requirement, I am choosing all those subsystems. So, using these components, the next immediate higher level components and subsystems are created or composed. So, when we are composing a lower level to higher level, at last at higher level, we can get a solution. So, that the process is continued till all the components and subsystems are composed into a single component, which is considered as a complete system. Anyway, at last we are looking for the complete system by integrating all the subsystems or submodules, whatever we have in the bottom-up approach. So, here you can see the diagrammatic representation. So, here we have a lower level, all these lower level subsystems is constituted together or integrated together to form a complete solution as a higher level system. This is a complete system. So, now we will see about the second type, that is with respect to top down. As the name indicates, I have one problem or my complexity of a problem is high. Instead of considering this as a complete problem, it will be divided into number of sub-modules until it will be easy for the purpose of management and to design or to find a solution for a complex one. So that each system is divided into several subsystems and components. Each of the subsystem is further divided into set of subsystems and components. Until we reach the final solution, it will going to be divided into further subsystem. So this process of division facilitates in forming the system hierarchy structure. It's like a tree structure. This will going to form a system hierarchy, and the complete software system is considered as a single entity, and in relation to the characteristics, the system is split into subsystem and the component, mainly to have a divide and conquer method, mainly to reduce the complexity. Complex problem or a system will going to be further divided into sub-components or sub-modules. All those sub-modules are tested, developed, and all the integration part will going to be done independently. At last, they will merge everything together to find the solution for the complex task. So here you can see how this top-down approach is represented in a hierarchy. So we have a module 1 that will going to be divided into module 2 and 3. Again, this module 2 is divided into 4 and 5. This is how further division of a modules or a subsystem will going to take place, mainly to minimize the complexity. So it's regarding top-down approach. And also we have hybrid designing hierarchy. That means if it is a combination of both top down as well as the bottom up design strategy, then we can say that as a hybrid design. And also it can be reusable. It will going to reuse the modules with the help of this top down as well as the bottom up. I hope you all understood my today's session and we are done with our unit 1. Let me meet you in the unit 2 in my coming session. Until that, keep learning, keep on growing. Thank you.